Good afternoon and welcome to the DevDays session with Ruchika Kharwar, Unleashing the Power of FHIR Data with Knowledge Graphs.
Thank you so much. Hi, everyone. Thank you so much for attending the session, especially on our day 4. It's an absolute honor for me to be here and an honor for me to have you here. So a little bit about myself. I'm Ruchika. I'm a customer engineer. I work for Google. I'm a data analytics subject matter expert. However, this session is not so much about Google Cloud and its products. It's more of an experiment. It's more something that I did as out of curiosity as to what if I did this with FHIR data. So this is what the agenda is going to be. It's going to be a very quick overview on what is a graph database, why I did a graph representation for FHIR data, and then I quickly go through some analysis and use case. I apologize. Something happened here.
Do you know where the hoof went?
The network. That's not showing up though. I see an encounter resource. I see a whole bunch of references. For example, in this case, I see a subject with a reference link. I see an individual reference link, which is to a practitioner. I see a location, and I see a service provider. So when I'm looking at this, I'm like, there's a lot of relationships here built into the resource definition. Now, this is another example I see. Okay, there are the obvious references that I see, but I also see potential for references in the original FHIR resource. These are more like properties in the resource in the form of coding. But I'm looking at those as potential relationships as well. Like, what if I coded up these codings represented in the blue in this picture as entities or nodes? And what if I built additional relationships? So these are some of the things that I was thinking through when I was looking at FHIR resources and wondering if it was a good idea to kind of represent it in a graph format. So here's what I did. I'm gonna kind of talk about what I did first. So I picked up the latest coherent data set, which has a whole bunch of patient JSON files. And I kind of picked that up and created resource mappings in the form of Cypher queries. And I loaded up about 1.8 million nodes, which represent a whole bunch of resources, and about 10 million relationships. Now I'll kind of dive deeper into the kind of relationship types and all that. But this is just a couple of metrics on the various resource types and numbers, etc. This is what I kind of got. I kind of loaded up all this data, and I just started to explore what it would look like when I have this data. So the first one I looked at was like, okay, what do I see if I have a patient? And I know that it's not visible here, but look, the yellow box, the yellow node here, circle is a patient. The green ones, the green circles are existing conditions. I kind of color coded the conditions to be which conditions are current conditions and which conditions are part of clinical history, just to give you an idea of the kind of things I started to do once I had this data mapped into graph. So I'm like, okay, let me figure out what conditions this patient has. Another example of what I did was, hey, I have a claim. I want to understand what is everything that's associated with this claim. So in this example, I have a claim which has a dollar value on it in the purple circle. And then I have these relationships like, okay, which encounters are part of this claim? What is the type of this claim? What's the priority? So this really helped me kind of visualize and understand more of the resources. So this was like, while I was building this, it was having a double purpose for me. I was like, what do I get if I represent it in a graph, and helping me learn the resource types. Now, I'm going to get into this a little later, but if I was to look at the broad strokes as to how we're accessing FHIR data today, right? So there's two main aspects, and I know there's subdivisions in that. So the first aspect, the first way of accessing FHIR data is through the FHIR specification itself, through the API. And the entire, like, I'm sure this whole room is very familiar with the specification, the chaining, the reverse chaining, and I'm sure it's a lot of fun using that FHIR search specification to kind of create your FHIR search API. The second way, the second broad way is to kind of export this FHIR data into an analytics warehouse in a way making that data SQL queryable. And one of my observations was that as soon as I did that, it led to a whole lot of other problems or leading to needing a lot of expertise in writing complex SQL queries. Because when I'm looking up a resource and I'm looking up traversing the various references in a resource, what I'm needing to do is a whole bunch of table joins. So that led me to wonder whether it was expensive, whether it was maybe impossible, and maybe that led to me needing to write SQL complex queries and even needing to manage those SQL queries. And I know there's other stuff happening like the SQL and FHIR and stuff, but these are according to me, these are the two main ways how we are searching and accessing FHIR data. Now, as part of the next exercise, I started to think about, okay, so I'm going to run through a few queries and see what makes sense in these two previous types, like on a warehouse, in a FHIR search, and on a graph. So the first one I tried was, okay, get me all female patients that are represented. And I found that this wasn't all that of a good query, because when I looked at it across all the three mechanisms, the way the performance and the kind of traversals it was doing, the kind of the number of lookups that were required seemed to be pretty comparable. So I kind of moved on to the next one. So the next one is find all patients with an observation code XYZ at a location, this hospital. So FHIR search is fine. I had to include an encounter, I had to include a subject, and I had to include an observation code, right? And the implementation of the FHIR search was up to what the underlying server implementation wanted to do. Now, if I went to a warehouse, I needed to have 4 table joins. I had to have a patient. The observation code is part of the observation resource. The location is part of the encounter resource. So I needed to join 4 tables: patient, encounter, observation, and the codes table if you have decoupled the codes from the observation. In a graph, I felt like it was a little bit more intuitive for me because all I had to do was kind of match the code, figure out find the relationships between using relationships to find which observations had that code, find encounters and match up the location. Great. I felt like it was a little bit more wieldy to use a graph for this situation. This other one, this next level, I was like, okay, I'm doing a lot of research and I find that patient everything is complex and everyone seems to have limitations on patient everything. So this next little exercise was like, okay, let me see what I can do with graph. And I found pretty easily that I could find everything associated with a patient up to a defined number of levels. And I know what you're thinking. I have to caveat that. And I quickly found that it was possible for me to specify in a graph, search up to these levels and stop searching if you hit this kind of a node. For example, if you start searching indefinitely and you hit an organization sort of node, please don't try to expand that further, stop at the organization node. But I kind of wanted to show you that this little statement here on the bottom right was pretty intuitive once I got into it to find and request, give me everything for a patient up to a certain level. This last use case is actually really interesting and close to my heart because I did a whole study in the last semester at school on opioids and substance abuse. And in speaking with someone I met, I've learned that the healthcare industry seems to have a bearing into the existing opioid crisis. And what I learned is that apparently the first time somebody is prescribed an opioid medication for whatever reason, it seems as a statistic that approximately maybe 20% of those people get hooked on for it for life. So this is a little exercise I did to figure out how easy it would be for me to search up all patients and track those patients over time after they got their first prescription for an opioid. So this was my goal, and I built around it. It's like I have a patient, find out when was the first prescription for opioids, and figure out what happened next. This was how I built up that relationship. I think somebody who's done something like this before would know it would be many lines of SQL to do that. But it was pretty intuitive for me to kind of first match up the medical code with code representing the opioid, find the first encounter with being referred to as part of the medication, referred to by the medication request, make the relationships between the patient and that encounter, and so on, right? And from so on, like that's my first codon encounter, and then I go on creating the remaining links between future encounters. I actually had a demo, but we kind of lost time on that. So I'm going to skip the live demo piece of it. But I'm hoping you can see that on the extreme left-hand side, I have a patient node, and the relationship on that path from the patient node to the first orange node is the first codon prescription. And then I have a timeline in the form of the orange circles with respect to every encounter and what type of encounter it was. The pink stuff represents what type of encounter it was, whether it was inpatient, ambulatory, etc. So basically my goal was, okay, can I get a broad stroke on what happened after the first one? So this, given I use synthetic data, it wasn't really possible to kind of figure out actual real insights and real impact on what could have happened. But what I want to kind of highlight here, how difficult would it be for me if I have this to find out, hey, what was this path before the first prescription? How does it compare to after they got this first prescription? How hard would it be for me to compare this same path for other patients who got an opioid prescription? And the bigger question is, how would it have made a dent, the ability to kind of ask these questions on the fly and be limited by the speed at which you can ask these questions? Would it have been possible to figure out and intervene in this whole crisis before it became a crisis? So this is an example of how I kind of generated this timeline. It's kind of a pretty simple query where I'd find the patient, find the first relationship, and chart out the next encounters. So again, this is kind of, this is what I keep asking myself. From a developer perspective, what is the real impact? How much query writing, how much management of those queries do I need to do? How much can better performance with this index-free adjacency help us? What about patient outcome? If we can really ask questions on the fly at a normal speed, how can it impact patient outcomes and crisis avoidance? I don't know how many other crises are in the making. We already have one on our hands in the healthcare world. Can we make a dent in the overall healthcare system? Overall, these are some resources I want to leave you with. I used Neo4j and Neo4j's Bloom feature for the visualizations I kind of showed in this presentation. Special thanks to some of my Neo4j partners, Anthony Krisky, Ben Lackey, Andrew from Cedars-Sinai, and the extended Google team, most of it which is here. Thank you, everyone.
I know we've run over time, but I think it was well worth it. I do have one question from the virtual audience that I could start with,
Yes.
and then I can run the microphone around to anybody else that has questions. The question is, did you use Graph as the operational database, an analytical database, or both? And if Graph was solely the analytical database, what was your operational database approach? And what was the experience transforming data from the operational database to the analytical Graph database?
Let me caveat this. This was a massive science experiment on my part. I did not have an analytics database or an operational database. I started with the synthetic data, which is I think 1100 something JSON files. And I loaded it into Neo4j, and everything I've showed here is based on that.
Wonderful presentation. Did you look at all at weighting the vertices in the graph?
Not yet, but that would be an excellent next approach. Yeah, not yet. So weighting the vertices, additional optimization, additional relationship building. But what I walked away with was it's much easier to do those things even after building the initial model. There's a question.
When you were bringing the data into the graph from the native JSON format,
Yep.
Did you have to map that to Turtle or some other RDF to get it into
No.
the graph format, or were you able to just do that from the native JSON?
I was able to do it with the native JSON, and I plan to, I forgot to add the link to my GitHub repository with those scripts, actually. I wanted to kind of give those scripts up. I use the APOC load module, which Neo4j has as part of their modules. It's available, it's open source. So I kind of use the APOC load module to kind of load the JSON, and I had some Cypher queries that goes through the JSON structure and creates my nodes and relationships. It was intense. I did about 17 to 20 of these resources. FHIR resources, I mean.
Anything you can share on the performance of the queries?
Great question. I was sure this would come up. In all of my jobs, so I used to be in microprocessors in my earlier part of my life, and doing performance was a full-time job. I was not able to do performance testing because performance testing really requires data at scale. It doesn't make sense to do performance testing with like 100 or 1,000 files. And that requires the next level of like access to infrastructure and stuff.
Another question from Huva. 20%, I believe, is the opioid recidivism rate. Is there a way to correlate what these patients had in common and lead to early interventions to prevent addiction?
I can't answer that question, but what I can answer is with this sort of data model and this sort of representation, it is absolutely possible to build upon whatever I just showed in the form of clustering algorithms. In fact, you could plug in GCP's Vertex AI as well on top of whatever Neo4j has to kind of build the machine learning model to compare various patients and cluster them into the various categories and based on the path they follow through. So this basically is foundation. It's kind of foundational to enable that sort of work.
Thank you. Just a follow-up question there. So once you had the data in the graph, have you experimented any with using the GraphQL operation to kind of dynamically create FHIR resources from the data in the graph coming back the other way?
That I have not done, but I would love to chat with you offline to figure out the use case for that.
One more question online. How do you see this relate to CQL-based analytics?
Quite honestly, I think it would be possible to have CQL sitting on top as an abstraction that is able to query and pull data from a underlying graph model. That's my initial take on it. But do you have a...
Hi, I'm KP. I used to be in the quality measure space quite a lot. So I think one of the big challenges with CQL, any measure, is that it is very rules based, and you kind of have to predict in advance, like how the data will actually look in each EHR, and it's very structured. And when you don't find it like that, it fails, which is why you almost always then have human abstraction and human in the loop, essentially making decisions about reading the measure and then comparing a chart. This, on the other hand, could make that problem much smaller, because you can actually have a knowledge graph. You don't have to know exactly how the data looks and like write your CQL measure exactly that way. So it definitely makes it much more scalable, truly scalable.
Yeah. And another thing is, like, and I'm thinking from the implementation standpoint, while I was building the graph, I kind of landed up using a lot of constraints. Like when you create stuff, make sure that you have these fields, otherwise raise hell. I guess that could be part of your SQL stuff also, like one aspect of it. Yes.
And one more.
I found it very interesting that you separated out the codes themselves. I myself have experimented a little bit with loading SNOMED into Neo4j. Would it be valuable to like combine the two to have like the relationship of SNOMED with the FHIR resources?
So so let me understand. You're asking about so you're asking about whether you should have the codes as part of the attributes of the FHIR resource or separated out as a separate entity.
Yeah, and also like importing the relationships between codes, like hierarchical relationships.
Oh, so you're asking about mapping and creating a relationship between coding systems themselves.
Yeah.
Yeah, I mean, that wasn't the focus of my exercise, but I don't see why it's not I see it's a great idea.
Yeah.
As we're at time, I want to thank you again for your presentation, and note that there are additional questions in Whova,
Okay.
and they're available for you to answer or to collaboratively seek solutions probably a month after the presentation is over. So thank you all for coming, whether physically or virtually, and have a great day.
Thank you so much, everyone.